Have you ever wondered if it's possible to travel across the universe in a blink of an eye? Welcome to the fascinating world of wormholes, theoretical tunnels with two ends, each at separate points in space-time. These aren't just whimsical constructs of science fiction, they are a direct prediction of Einstein's theory of general relativity. So what exactly is a wormhole? Picture space-time as a two-dimensional surface. Now imagine bending that surface so 2 points are brought together. The shortcut connecting these points? That's a wormhole. They're considered as shortcuts through space-time, providing a path of least resistance between two distant points in the universe. But it's not that simple. While wormholes are solutions to the equations of general relativity, they're inherently unstable. Without some form of exotic matter with negative energy density to keep them open, they would collapse in on themselves faster than light could pass through. This is where the theory meets the boundary of our understanding and ventures into the realm of the unknown. So, if they're so unstable, how could we possibly use them for travel? Well, the truth is we don't know yet, but the potential is tantalizing. If we could stabilize a wormhole, it could provide a bridge to another point in space or possibly even another universe, allowing for faster-than-light travel. Imagine hopping from one galaxy to another in less time than it takes to make a cup of coffee. But let's be clear, we're still far from booking our tickets for a wormhole cruise. Although they are theoretically possible, we have yet to discover any concrete evidence of wormholes existing in our universe. This is the frontier of physics, a place where theory and observation have yet to meet. So, wormholes are not just a figment of our imagination, but a real possibility. But how do they form? Stay tuned as we delve deeper into the enigma of wormholes, their creation, and their potential to revolutionize our understanding of the universe. A wormhole is not born, it's made. Now you might be wondering, how does one make a wormhole? Well, that's where things get interesting. Let's start with the basics. In the realm of theoretical physics, wormholes are hypothetical structures linking separate points in space-time. They're like shortcuts through the universe, allowing for faster-than-light travel and even time travel, at least in theory. But creating a wormhole isn't as simple as punching a hole through a piece of paper. It requires something called exotic matter. This isn't your everyday run-of-the-mill matter. Exotic matter is thought to possess negative energy density and large negative pressure. These properties are crucial in keeping a wormhole open. Without exotic matter, a wormhole would be highly unstable, collapsing in on itself almost as quickly as it forms. It's like trying to keep a tunnel through a sand dune open without any supports. The sand, or in this case the fabric of space-time, would quickly collapse in on itself. But exotic matter, with its negative pressure, acts as the support holding the tunnel or wormhole open. Now, where do we find this exotic matter? That's still a mystery. Some theories suggest that it might exist at the quantum level, in the frothy sea of particles and antiparticles that constantly pop in and out of existence in what we call the quantum foam. Wormholes themselves might also form naturally in this quantum foam. At the tiniest scales, smaller even than a proton, the fabric of space-time is thought to be constantly bubbling with tiny wormholes. These wormholes, however, are incredibly small and fleeting, disappearing almost as soon as they form. So to sum up, the birth of a wormhole involves exotic matter, negative energy, and the quantum foam of space-time. It's a fascinating and complex process that challenges our understanding of the universe. That's how wormholes come into existence, but can we use them for travel? Well, that's a question for another scene. Stay tuned. Imagine stepping into a wormhole only to be crushed instantly. Not a pleasant thought, is it? Yet, this is one of the potential dangers that wormhole travel presents. Wormholes, in theory, are like cosmic shortcuts, promising to whisk us across the universe in a blink. But they come with a caveat: high radiation levels. This isn't your average sunburn kind of radiation. We're talking about levels potent enough to obliterate any living creature. The exotic matter that keeps wormholes open also emits high-energy particles, which could be deadly to any would-be explorer. Then there's the issue of extreme gravitational forces. These forces could squish you into a spaghetti string thinner than a strand of hair. Known as spaghettification, this process is as unpleasant as it sounds. It's the kind of extreme makeover no one would sign up for. And let's not forget the potential for a sudden collapse. Wormholes are inherently unstable. They could snap shut at any moment, trapping travelers inside or even obliterating them completely. It's like playing cosmic Russian roulette with the universe holding the gun. But don't lose hope just yet. Theoretical physicists have proposed some possibilities for safe wormhole travel. One such proposal is the use of advanced technology. This would involve creating a wormhole and then stabilizing it with negative energy or exotic matter. This is all hypothetical, of course, and hinges on technology we don't yet possess. Then there's the idea of a naturally stable wormhole. These are thought to be possible if the wormhole is filled with phantom energy. This mysterious form of energy has a negative energy density and could theoretically keep a wormhole open. So wormhole travel is fraught with danger, but it's not entirely off the table. In the end, the exciting potential of wormholes is matched only by their inherent perils. It's a risky business, this universe hopping, but isn't that the very essence of exploration and discovery? Could wormholes be our ticket to not just distant space, but also distant times? Now that's a question that has piqued the interest of scientists, authors, and film directors alike. But how could wormholes, these hypothetical cosmic shortcuts, facilitate time travel? Let's dive into the heart of the matter. Imagine a wormhole, a tunnel with two ends, each in separate points in space and time. It's been suggested that if one end of the wormhole were moved at relativistic speeds, close to the speed of light, or placed within a strong gravitational field, the passage of time at each end would differ. Why would this happen? Well, it's all thanks to our friend Albert Einstein and his theory of general relativity. Einstein proposed that gravity is not just a force, but a warping of space and time by massive objects. This leads to the phenomenon we call time dilation, where time slows down in stronger gravitational fields or at higher speeds. So, if we could manipulate one end of a wormhole in this way, we could, in theory, create a kind of time machine. Enter one end, and you could emerge in the past or the future. But before you start packing your bags for a trip to the Jurassic era or the far future, remember that this is all theoretical. We've yet to discover a wormhole, let alone figure out how to keep one stable or move one end at near light speeds. Then there's the question of what would happen if you tried to travel through it. Would you survive the journey? Or would the wormhole collapse in on you, leaving you in a cosmic limbo? There's still much we don't know about wormholes and their potential for time travel, but one thing's for sure, they provide a fascinating glimpse into the strange and wonderful possibilities of our universe. Wormholes could be much more than cosmic shortcuts, they could be time machines. As we stand on the precipice of the unknown, what does the future hold for our understanding of wormholes? The journey of scientific discovery is never-ending, and wormhole research is no exception. Our understanding of these fascinating cosmic phenomena is still in its infancy, but with every passing year, we inch closer to the truth. Currently, physicists are exploring several exciting avenues of wormhole research. One such avenue is the search for natural wormholes. These theoretical tunnels in the fabric of spacetime could be lurking anywhere in the universe, potentially providing shortcuts between distant galaxies. Scientists are using advanced telescopes and detectors to look for the telltale signs of a wormhole, such as distortions in the light from distant stars. Though we have yet to find conclusive evidence, the search continues, fueled by the tantalizing promise of what discovery could mean. On the other hand, we're also investigating the implications of wormhole technology. If we could create and stabilize a wormhole, the possibilities would be staggering. Imagine a future where interstellar travel is not only possible, but commonplace. A trip to the furthest reaches of the galaxy that currently takes millennia could be shortened to mere minutes. The implications for exploration, communication, and even commerce are mind-boggling. But let's not get ahead of ourselves. The creation of a stable, traversable wormhole is still purely theoretical. We're dealing with forces and energies on a scale that are currently beyond our reach. However, our understanding of the universe has always been propelled by the seemingly impossible. Studying wormholes isn't just about the potential for galactic shortcuts, it's about pushing the boundaries of our knowledge, testing the limits of our theories, and constantly striving to understand more about the universe we inhabit. It's about maintaining that spark of scientific curiosity and exploration that has driven us from the dawn of time. In the quest to unravel the mysteries of the universe, wormholes may just be the key we've been looking for.